All right. Okay. So it looks like we're back. So to class, we are just going to go through traffic signal warrants one by one. And we are going through section 4 of the MUTCD, which talks about general guidance, support, and an option. So support is just supporting material, as I said, and guidance is where you'll have shall or shall not, which is mandatory requirements. And then there is more loose guidance in the form of should or may, those kind of things. And then option will be generally be, something may will generally come up in the option case, is what's going to happen here. Now, as you're going through it, there is some good information in that segment 4 or chapter 4, not chapter 4, part 4 of the MUTCD that I've shared with you earlier. There is advantages and disadvantages. There are some alternatives to consider for traffic signals. So look at those. And then adequate roadway capacity. And then what we are interested in chapter 4C, which is all the traffic signal warrants, okay? So, and now, if you're wondering why we are dealing with already like traffic signals and all that, and when we're talking about traffic studies, because traffic signal warrants require you to interpret the results of traffic studies, okay? So what I've shared with you today is a sheet of paper, basically a problem, in-class problem where you're conducting signal timing analysis. And all it does for the most part is provide you with the results of a traffic volume study, okay? There is traffic volume study, the results of which are provided to you. And now you're just sort of, and then there is obviously collision data as well. Now your goal now is to be able to interpret that data from that traffic study to decide whether or not our intersection meets the signal warrant or not, okay? So that's why we are sort of doing that here. So let's see if we can quickly learn some background on it and then go from there. So traffic signal warrant. Obviously, in intersection, we are talking about separating conflicting traffic through specific assignment of right of way, right? So that's what traffic signal is trying to do. It's deciding and letting everybody know, all road users, who's going to have right of way. And then sometimes you could, all these grade separation, special separation, they are kind of pretty, how should we put it? Like they are pretty expensive solution. I mean, that's not to say signals are not expensive. Signals are also pretty expensive, but grade separation is even more expensive, right? Like providing a whole overpass or underpass can be pretty expensive. So, and traffic control devices is how we are doing. So we can do it either using a signal, or we can use it using via traffic signs or other sort of, and your signs could be stop sign, your signs could be yield sign, so, but they're all traffic control devices. Okay, so they are sort of considered to be traffic control devices. So, and then signals will be a signalized intersection is where we are using signal as a traffic control device. We talk about advantages of traffic signals. So anytime you're seeing, so in these traffic signal warrants, you're going to read some language where you're going to see, okay, reduce frequency of crashes amenable to be improved through the use of a traffic signal. So what are those crashes? Those are your crashes, right angle crashes, T-bones, and then left turn, head-on crashes when somebody's making a left turn and somebody's going through the location. And those are the type of, and then something that's, two people are going in a 90-degree direction. So those are the two types of crashes that are most amenable through the use of traffic signal. Yes?
Doesn't it also help prevent auto ped crashes?
It could prevent, definitely, it could prevent auto pedestrian crashes as well. So yeah, these are obviously talking just about the vehicular crashes, but you're right, like, it could prevent potentially the pedestrian crashes, but by itself, it may not. So you might have to provide other, sort of improvements to the signal, like, for example, LPI, which we call the leading pedestrian interval. And you probably have experienced that, right? LPI, which is where the pedestrian signal comes on first before cars start moving after a red sign. Yes.
Can you just have the protected left turn phase lead the pedestrian interval?
pedestrian, protected. So
So just have the protected left phase just go first for the ped, so you completely remove that conflict.
yeah, I mean, you'd never want, so if you have a protected left turn signal, you would never want to have pedestrians going at the same time. Because that's a conflicting movement, and then you don't want to put a green arrow to it. Yeah, but there might be permitted left turn that sometimes is allowed, right? So there is sometimes permitted left turn that's allowed while the pedestrians are going on the opposite movement. That sometimes could happen. But again, that's a problem too. But you can still take care of that a little bit by providing that leading pedestrian interval where the pedestrians can be a little bit further ahead, where the drivers can see them and not just start right at that time. So yeah, but so those are the types of crashes that can be amenable by the use of traffic signals. And as was said before, signals can help with pedestrian crashes as well, but you have to be careful that, if you're providing right turn on red, those kind of things might actually not help the pedestrian. So something to be thinking about. Now, even though we're not talking about these ideas, these same studies, like we're not talking about how we are going to do signal control, like whether it's going to be, so I shouldn't say type of traffic control here. I should probably say type of signal control here, okay? A signal control could be pre-timed, and that's how, the first signals that were designed in the world, really, they were all pre-timed, sort of, they used to go at any given time, like 20 seconds to this route, 30 seconds to this route, or whatever. The split was decided based on the demand. Then they got a little bit more demand responsive. They said, okay, during peak hour, we're going to have this type of signal, and then we'll program it so that, or we either will program it or somebody manually will change the configuration so that maybe all phases get equal time during non-peak hours or something like that. But obviously now we have way better technologies where we can do something called actuation. And those are sort of detector or camera-based actuations. And you will see the cameras in SLO, in San Luis Obispo. Most of those cameras are, in fact, used either for just kind of visualizing the traffic conditions for the traffic engineer in the city. But some of them I know are also used for actuation purposes, is that deciding where the demand is and just sort of giving the green to that. So actuated means just demand responsive, right? So that's why you might have seen, like, if you go on a midnight at an intersection on a minor street, the right would be red, but as you approach it, you just stop, the signal will sort of cycle through and give you the green. Yes.
What do you do, I guess in the modern age, when you use pre-timed signals in a situation where you have a street, multiple lights, and you want to synchronize it, so when
That's exactly right.
Limit,
Yep, that's exactly right. Yeah, so pre-time signals. So that doesn't mean that, we never want to design pre-time signals, or we never have pre-time signals. We do, and those pre-time signals would be in place where you have the coordinated signal system, right? Where you have 5, 6, 7, or 8 lights, one after the other. And on those lights, you have, a sort of a pre-timed, and they are pre-timed. All of them are synchronized with each other, and they work on the same signal cycle. And then they have some kind of a differential between when the yellow light will occur from one signal to the next from the lead signal, right? And we'll talk about actuation and actuation plans in the class as well. So we'll get some information on that. But today, because this focus is signal warrants, here, what I'm going to do is, like, as we're talking about this data that we have collected to do the signal warrant study, sometimes that data can also tell you what type of actuation might you want on that approach. So for example, if you have a wide disparity persisting throughout the day between the major approach and the minor approach, where major street traffic is always very, very, very high compared to minor street traffic, and you're putting a signal at that location, that means you almost certainly want to provide at least a semi-actuation on that signal. You never want to give both sides the same thing. And then one more thing about this is that in terms of pre-time, right? A lot of times, even actuated signals, especially during peak hours, will run as pre-time. Why would that happen? Because in actuation, we specify something called a maximum green time. A maximum green time for the signal for each approach, for each signal phase. And then during peak hour, especially in urban areas where the demand from all directions is pretty high, every cycle, all phases just max out. And that's when the signal turns yellow, right? So that means for at least that particular time frame, those signals are essentially running like pre-time. So even though we rarely have signals just by themselves to be pre-timed anymore, like an isolated signal in a rural countryside will never be pre-timed anymore. We still want to be able to learn how to design pre-time signal because, or at least know what pre-time times we want on those, because we'll need to figure out what is the max green time for each approach that we want to provide it, right? And those timings basically work like pre-time. But again, here my interest is to kind of just look at the traffic study data that we are going to be using and use that information then to decide whether or not what type of actuation we want to provide. Okay. Pre-timed approach and clock, actuated makes a detector, sensor, videos, whatever, right? So some kind of detectors are in place, right? It may be buried in the road. You know, you could probably spot those actually. If you go through bike paths, even there are bike detectors now, but you can spot, like, you know, there will be some kind of marking on the road that will be seen. And these detectors are essentially magnetic loops where when a metal passes through them in a car or a bike, whatever, and then those detectors get triggered. And then when they're triggered, they send the signal to the controller that, hey, you know, this approach needs green or whatever, right? So that's the idea. And sometimes, as I was saying, there are video detection at all approaches, or some approaches would be semi-actuated. And then you basically are serving, you're adapting to the demand, essentially. That's what you're trying to do. And then usually when side street traffic is relatively light, that's when you use semi-actuated signals. Again, that's when you're reading the results of the traffic signal control study or signal warrant study. That's when you're using. So masked arm traffic signals. So, you know, you might want to have to provide those. This is typically how most modern signals are provided. You know, this is the safest design, you know, for the most part. And then easily visible. You know, there is this diagonal span traffic signals could be useful, but again, maybe not as secure in windy weather and stuff like that. Yes.
They're also a lot cheaper.
Right. These signals, right?
Yeah.
Yeah.
Wire span signals.
Yeah. Well, wire span signals are way cheaper, but to the extent possible, we try to provide, you know, the masked arm. Masked arm, obviously, way more expensive. Yeah, that's a good point. And we have these, you know, typically in rural areas where you don't expect inclement weather. And then pedestrian signals, walk and don't walk. We typically are accompanying the walk and non-walk signals with timing now, so that the pedestrians have an idea how fast they need to go to. So instead of just sort of having flashing hand, you just provide like a countdown timer. Yes.
I believe California MUTC requires by standard that all new PET signal installations have to have the PET countdown.
I would not be so sure of that because I haven't looked at that, but yeah, that might be true. We probably, so as I said, like in California, it might be required if you're following California MUTCD that if you're doing a new PET signal, you need to have a countdown timer on it, right? And that technology, again, in the scheme of things, adding a countdown timer is not that big of an expense. So I think this is something that's useful, provide great guidance to the users. So it should be provided, and it is provided. And then, as was said, in California, it shall be provided as if you're installing a new PET signal. So traffic signal should not be provided unless one or more warrants are met. But even when warrants are met, you can choose to provide, not provide the signal. Okay, so as a traffic engineer, MUTCD provides a lot of guidance and tells you, hey, do not provide the signal willy-nilly. Be careful in when you provide the signal. And they are about they say even if you meet the warrant, you can choose to not provide the traffic signal, and that's okay. Okay. Sometimes that's a good thing. Sometimes that's not a good thing because, again, signals can help pedestrians, can help vulnerable road user more in some circumstances. But again, in a lot of places now we are seeing sort of a movement towards roundabout, and a lot of places, they could be a good. Roundabouts, the downside is that roundabouts have sort of higher initial investment because you might have to acquire a bigger right of way, possibly. But if the right of way is available, maybe roundabout becomes somewhat competitive compared to traffic signals. And then roundabout don't have as much ongoing maintenance compared to the traffic signal and use power usage and all of that. Yes.
Or like the head for warrant 4, could that be like where if it meets the warrant, but would it so saying that traffic signal should only be one consideration, like, for instance, like if it meets the head warrant, then
Yeah, so a lot of times, I don't know about ped warrant specifically, personally.
the warrant 4.
Yeah, no, I'm just saying, like, if you are meeting the ped warrant, no, I know ped warrant specifically, yes, but what I was saying is that I'm not sure if ped warrant is the one. If you're meeting, you probably should be providing the signal, I think. And again, that's left to the judgment of the engineer. But I would say that as a good traffic engineering judgment in that case would be to provide the signal, because signals still remain a traffic control devices that is much better, has a much better rate of obeying compared to any other type of traffic control. And pedestrians need to be protected on the road, right? And given the crisis we have with pedestrian fatalities, I would say if you're meeting the ped warrant, yes, you should probably consider putting a traffic signal there, no questions there. But I think some of these other vehicular traffic warrant, specifically the one, for example, number 3, like the peak hour warrant, that is, a lot of DOTs are actually getting rid of that warrant. And they don't even consider peak hour to be a determining factor, for example, right? So all of this to say that even if you are meeting one or more of the warrants, you have the judgment, you can exercise your judgment to not install the warrant, justify your reasoning, and then talk about it, right? So you could mention it, no problem, right? So if you're seeing, for example, if you are just meeting the peak hour warrant, you are not seeing collisions that are amenable to be improved by traffic signals, then you could say in the warrant that, hey, the only warrant I'm meeting is peak hour warrant, and that basically just a delay, automobile delay for 1 hour of the day. And then I'm not seeing any safety issues with regards to left turn crashes or pedestrian crashes or whatever. And that's why we are choosing not to install a signal. That will be a legitimate argument against not providing a signal, right? So you always have that judgment that you can exercise. So what type of data should we collect? So you can, once you go through the list of the traffic signal warrants, you start to see that. So here is some data to collect. So that's 12-hour count for all approaches. So you need at least 12-hour counts done over maybe 2 or 3 days, maybe averaged out, whatever. So you need to do that. 12-hour count on all approaches. Turning movement count for AM, noon, and PM peak hours, including classification, whether it's AM, whether it's PM, whatnot. Pedestrian volumes, elderly and disabled individuals, if they are there. So that's another consideration you might have. 85th percentile speed as you approach the signal. So a little bit far from the signal. Make sure that you know what is the approach speed to that signal. Nearby facilities, like, what's happening, where the school is, if there is a railroad crossing. Condition diagram, like, what is the typical condition of the roadway, lane configuration, all that. And collision diagram, like what are the historical collision at that location. So this is some of the data that you want to obviously look at when you're thinking about running a signal warrant. And again, we are doing this in this module because, again, it's a traffic study that we are trying to interpret the results of. So again, this is available online on your... So these are your warrants, 9 warrants. Now, I have to tell you something. MUTCD should be coming out with a new version, which would have different warrants, right? So these warrants is a good chance. There's a very, very good chance that you will not be using these federal warrants in the future, in the very near future, actually, because the MUTCD that we're using right now, it came out in 2009. So that's almost 15 years ago now, 14 at least. So because of that, and they're coming out, I know they are in the place where They have the new MUTCD that just hasn't been released to the public. I've seen it as my work as the chair of the Traffic Safety Committee for the Transportation and Development Institute, provided some comments to the MUTCD at the time on different aspects of that manual. And so this is something that is about to change. But again, even if there are changes, I think the skills that I'm trying to get to you is how do you read a technical document like this, like the section 4 of part 4 of the MUTCD, and make sense of it. Even though the specific information will change, we know for certain it will change when you practice, but just kind of having the practice of applying the MUTCD is what I'm after right now. So for now, we're going to assume that these are the warrants in place because they are the federal warrants as of today, but they are about to change. So just make sure that you are aware of it, and that's going to happen. Yes. I think the timeline should be, I'll have to go back and take a look, but I'm almost surprised that it hasn't come out yet. It should be come. Yeah, right about that time. Yeah, I think 15 years is probably sounds about right. Probably sooner. It should have been a little bit sooner. So yeah. And then, again, because you have that, engineering judgment, they let you do that. So there is sort of, you could, so let's say if you figure out a treatment for roadways and you want to implement it in your location, you can request the FHWA to experiment something. And then you could justify your experiment. They will ask you to collect certain data on it. So what I'm trying to say is that, yeah, so these manuals come out every 10, 15, 20 years, whatever. But it doesn't mean that, your practice has to be fully static during that time. There are treatments that you could implement. Yes, 4 years. What's that? It's every 4 years they want to have MUTCD out. 4 years. Okay. So yeah, learn something new today. So they want to update everything every 4 years now, which is kind of, but the last one did come out in 2009. And I think perhaps they're looking at the collision data and seeing, okay, yeah, that's probably too long of a wait to do. So, but again, even within that time frame, and there are obviously have been corrections since, like you could look at the corrections that have been made in the 2009 version of it. But even during that shift, like, when the same MUTCD is in place, you could potentially request the FHWA to experiment with some things into the community. And that's how sort of, so you wouldn't find edge lane roads in the MUTCD, for example, right? But edge lane roads have been implemented on experimental basis, and then the communities are required to collect some data on it. So, so here we're talking about the warrants. Warrants are 8-hour, 4-hour, peak hour. These 3 warrants are basically the same thing with different numbers. So if you meet a certain condition for 8 hours, if you meet a more intense condition for only 4 hours, if you meet an even more intense condition in terms of traffic volume for just 1 hour, right? That sort of is the progression of the first 3 warrants. So they're all looking at traffic volume data for different periods, 8-hour, 4-hour, and peak hour. And if you, so 8-hour warrant will be certain number of threshold, certain threshold to meet. 4-hour will be even a little bit higher threshold. 1 hour will be an even higher threshold, right? So per hour. So, and then there is pedestrian volume and school crossing, coordinated signal system, crash experience, roadway network. Roadway network is basically these warrants, but in the near future. Like, if you expect, you don't meet the warrants today, but there is a Walmart coming up or something, right? So you could put in anticipation of that development, that change to the network, you could install a warrant, because if in the very near future, you're going to start meeting that warrant. So that's something to apply. And then intersection near a railway, highway grade crossing. So that's another warrant number 9. So 8-hour volume, vehicular volume. So what we'll do is, to do this, we'll just sort of look at the conditions themselves. So let's look at traffic signal warrant number 1, which is starting in section 4C2. Everybody should have the handout that I distributed the other day, not today, but last week. you have it, please make sure that you have it open. So I'll give you what I'll do is like I'll give you like maybe 1 minute, and let's read through it. And what we'll do then is we'll also look at the problem that we are dealing with. Okay. So this is the problem that you're working with. This is the data that I shared with you guys in the handout today. Now we're just gonna sort of run through this data and try to see which conditions you're meeting. But before we do that, a couple of things I want to note here is that some definitions might be maybe not so clear. Like, so for example, what do you think should be, what are we looking at in terms of major road approach volume, minor road approach volume? First question is, okay, what's major, what's minor, right? Yeah, major is obviously the one that has more volume, right? Yes.
Or typically, not always the case where it has more volume, because depending on the time of day, it may vary, but it's the road that typically in this situation will be free flowing, while minor is typically going to be stop control.
If there is a two-way stop control. So that's another way of sort of thinking about major versus minor, right? Is how the existing right-of-way is a sign. Is that a stop sign? A lot of time, they will get you to the same answer, right? A lot of time. But sometimes could be interesting. Sometimes the interpretations could be interesting in that sometimes we might have to think about signalization, and your major and minor might not be two different roads at all. It might be that your major is the through volume on street A, and your minor is left turn on the same street from the opposite direction. So you would see some examples where your major and minor volume, that based on which you're doing your warrant analysis, it's possible that you might see example cases where your major and minor, your minor and major might actually be, so it's not just about always that the two roads that are meeting will have the conflicting traffic, potentially, and it doesn't, always happen, because minor road will have traffic and all that, but it could happen. You have to be mindful of the fact that sometimes your major minor road approach could be the opposing left turn traffic as well. Okay, so your minor sometimes for the purposes of applying the warrant might be coming from the opposing left turn lane, because that might just have so much volume. Okay, and then obviously you'll have to provide protection for that approach and all of that. And then obviously that left turn also opposes the traffic on the minor side, the other side street as well. So there might be something to that. Obviously that's not the case here. So we are okay. I think here we can clearly see that there is one approach that has the minor and the major. Now, when you talk about the lanes, right? How do we determine the number of lanes here? So if you look at the MUTCD tables, for example, so if you go back to the actual handout here, what you will see is that you go to the traffic signal warrant handout, you come down here, you look at the table, you have the number of lanes, right? Number of lanes could be tricky as well, but typically what we do is we're just start sort of seeing like how many lanes is this traffic divided into, right? So that depends on, so total of both approaches is for the major. So that would depend on the minor load. A lot of times we'll just sort of add the right turn traffic, right, with the true traffic, and ignore the right lane completely. Okay, because we know that traffic sort of moves with the right turn direction. You could potentially apply some kind of a correction factor for the right turn traffic, some kind of an equivalent, but that's almost like you're trying to fudge the number to get your warrant met, and not great practice, not ideal typically to do that for the warrant analysis. Obviously, you know that right turning traffic moves a little bit slowly compared to cars that are just going through. So there might be something to that, but typically we try not to apply any kind of correction factor, like a bumped up factor for the ET or equivalent, not ET, ER rather, equivalent right turning to the through vehicle, right? So we don't typically do that just for the warrant analysis. We might do that for the level of service analysis and all that, which you learn about, but for warrant analysis, typically we don't do that. So what I wanted to do then is look at this table that I provided you here and just sort of go and take a look at and go through each hour of traffic, and let's decide which of these hours meet the warrant versus which of these hours don't meet the warrant, looking at the table 4C1. Okay. So let's look at condition A and condition B both. So let's start off with condition A. So let's see. What's the first hour, in your opinion, that meets the condition A warrant of minimum vehicular volume? Is there one? Okay, wait, let's kind of hear from some other folks here. Which is the first hour? Yes. 10 to 11. Okay. There should be one before that. Okay. Anybody else wants to talk about which hours? So I'm looking at this table right here, and I'm trying to figure out where, from starting at midnight, all the way going through the 24 hours of the day, which is the first hour of the day that meets condition A. Yes.
Yes, first hour of the day, condition A is met at 56%. At 56% is met at 5 in the morning.
Right. So 56, but 56% has to be. So remember,
A and B, and or if you're doing both condition A and B at 80%, and the 80th percentile speed of the major road is about 40 miles an hour, which we're given that the 80th percentile speed split.
Okay, so there's a lot going on here, right? So what's going on here is that first you have to think about all the information that's provided to you. So if you look at that condition, the speed limit for the major roadway is 50 miles an hour and 45 miles per hour for a minor roadway. Okay, so those change things, right? Those change things because to meet the first warrant, then
it's an option, but
yeah, it's an option. Yeah, that's exactly what I was getting at. It's like, so that's basically what you're getting to, is like you can meet that a little bit earlier in the day if the posted limit or 85th percentile speed on the major street exceeds 40 miles per hour, or if you are then you can meet the warrants not at the regular level, but at an 80% level. Okay, so a warrant is considered satisfied at a lower volume threshold. I hope that makes sense, right? If the traffic is moving fast, right, then to keep it moving, you would consider providing a traffic signal at a lower volume threshold. Okay, so that's what it means. Like, and then this 56%, you might be thinking that seems like a random number, but hopefully you can even guess where that 56 specifically came from, right? Can anybody guess where 56 might be coming from? 80% of the 70%. Right? Because the volume, if you look at the tables, that, the minimum traffic vehicle volume condition A is intended for signal large volume intersecting traffic is the principal, and then So if condition A is satisfied, then warrant is A is satisfied. Analysis of combination B are not needed, right? So if condition A is met, then you've met the warrant, right? Met the warrant if it meets for 8 hours of the day, if condition A is met, right? Similarly, if condition B is met, then you've met the warrant as well. But combination of A and B is also acceptable when this happens. So again, you can start to see some wording about shall be considered. Again, they're giving you an out. They're not saying shall be installed, right? They're saying shall be considered. You could still say, okay, we considered it and did not install it. And that's going back to that point one more time, is that you could choose not to install a traffic signal as a traffic engineer if you think that's not an appropriate thing to do. So again, shall be considered means you absolutely have to consider it. So anytime they put a shall in there, that means you have to do it. But again, they're giving you an out by doing shall be considered. Okay, so you're considering it. Okay, so and then there is this option of if the speed is pretty high, or there is another condition if it's an isolated rural communities of population less than 10,000. And what do we mean by isolated? Is basically you're not talking about like, in the Los Angeles County, for example, there are like, cities changing like every 2 miles or whatever, right? So there might be less than 10,000 population in that small city or whatever, right? That's in Los Angeles County. But this is all contiguous areas, fully developed. When you're switching from one city to the next, you don't even know, right? So that's not what we're talking about. We're talking about isolated rural community of less than 10,000 population or speed limit being pretty high. Either of those conditions, you can consider, you may be able to bring down your threshold to be, 80%, 80% level. So you're not sort of bound by that condition. You can consider the warrant at a lower level. Okay. So let's now think about, so let's say if you're not doing the 80%, let's say, it's an option because the speeds are high. It's an option that you could consider the warrant. What if you don't consider that as an option? Then when do we meet the first warrant? Then when do we meet condition A? Yeah.
You first meet condition A at 80% at 10 a.m.
Yeah, that's what, yeah. So 10 a.m. is good, it's like 80% condition. So let's look at condition A. What is the threshold? So which lane are you considering here? What number are we looking at?
Major road approach volume.
So major road approach volume total on both directions, right? Right. So major road, and again, that's how this table is set up. So if you look at that table that I shared with you, that's major road on both direction, traffic volume, 10 o'clock. Let's see what the volume is. At 10 o'clock, the volume is 550. So basically, you're meeting that condition at 80% level. What is happening at the minor street at that time? Minor street at that time is at 210. What's your threshold for minor street at that time?
120.
120. So that means you're meeting both at 80%. You're meeting both at 80%. And then that means, and then how do we know, like, if the number of lanes are okay, right? So number of lanes is, B street is considered 1 lane traveling in each direction. And then approach A street considered 2 lanes traveling in each direction. So that means that's why it's a 2-1. So that's what, remember, it's traveling on each approach. So that's why I'm looking at this part of the table. And my 80% condition is met 480 and 150. So I'm meeting both of the, I'm meeting that condition at 80%. Okay. What about condition B? Am I meeting condition B at 10 o'clock too? What about condition B at 10 o'clock? Am I meeting condition B at 10 o'clock? At that 10 o'clock hour? Yes or no? No, right? Can everybody see? It's very important that you see that condition B is not met at 10 o'clock hour, right? So what you'll do is then you'll start sort of going down the pike and start seeing, okay, where are we meeting the first condition, and where are we meeting the warrants here, right? So you could start like, okay, yes or no, you could start putting in condition A met or condition B met, and then you could see if that is happening for 8 hours of the day, and that's what you're going to do next. Okay, so let's see if you can do this analysis for all hours of the day, and then let's look at that 80% condition as well. Like, let's say if you want to exercise that option of a lower threshold. Okay, I know I'm sort of switching between the two things because there is a lot going on again, so just be careful. You just have to pick one idea, like, okay, are you considering this as a high speed or a rural community or not? So, and then you sort of solve that problem according to that. So in the exam, if I give you a problem, and if I give you the same speed limits, for example, right, you will just at the beginning of the problem, you'll tell me whether or not you're considering this to be high speed or a rural area. And then you solve your problem throughout the problem using that assumption. You just kind of stick with that assumption. You should be able. Now, if I give you that, yeah, you must use that option, you must use that 56% option, then you will use it. Otherwise, if I don't specify either way, then it's your option. You could exercise that option or not exercise that option. Results obviously would be different, right? Results obviously would be different based on that. So what I want you to do next is just sort of for each hour of the day, starting maybe at 5 o'clock in the day, put yes or no for both condition A and condition B. And let's assume for now, we want to exercise that option, that it is a high-speed community or a high-speed approach on both directions. Okay, so let's exercise that option of the 80%, and now start telling me, starting at, let's say, 5 o'clock in the morning. So start from 5 o'clock, put yes or no for condition A, yes or no for condition B, and then if both are meeting, then we'll see about that too. So let's take a look at that. So I want you to fill up that information as you're doing that. Okay, so let's take a few minutes, make sure that we can do that, and then I'll probably just walk around, see what you're thinking, what's going on. So one question is, what's the difference between the standard here? Hit that. What's the difference between the standard right here? What's the difference between the standard right here and right here? Very little difference except for this word right here, or, and here you have and, right? So you can meet the warrant by meeting either one of those conditions at 100% level, and you can also meet the warrant by meeting both of these conditions at 80% level. Now, in this example, because I said, yeah, assume that this is a high-speed approach facility, which it is, and exercise that option. That means you're not going to look at 180 columns. You're going to look at, you're looking at 70 and 56 columns. Those will become your 180 columns, right? Because that's what it says here. So if you look at the option, the traffic volumes in 70% columns in table 4C1 may be used in place of the 100% column, right? So if you are in a rural area, this is what happens. And then same thing here. If you're in a rural area, 80% columns would be replaced with a 56% column. Yes.
You should not even, like, let's say it meets at 70%, you have to also check for the 56 or stop there.
Yeah, no, if you meet one of those at 100%, then you don't need to check for the combination. The question is, this is right here. It is entitled the warrant 1 between a single warrant. If condition A is satisfied, then warrant 1 is satisfied. Done. Then it's 1. Yeah, so if you want condition A is satisfied, you're done. If condition B is satisfied, you're done, right? But then if A or, you might need to do a combination of A or B if those conditions are not satisfied for 8 hours of the day, right? Then you have to look at the combination of the two. Okay. I didn't get to everybody, but let's see if there are other questions, comments. It's a good idea to kind of think about this a little bit more deeply. It's complicated a little bit, right? It's not, the language is not always easy. It's hard to see what they're talking about. What is the difference between the two different things that read pretty much exactly the same, except for that one word between and or. Again, a lot of practice is required, so you'll get some of that in the class and in your homework problems. But are there any questions? Yes. A condition that is in italics before the second standard. You're talking about this one right here? Yeah. So combination of A and B is intended for applications at locations where condition is not. Okay. So this is, again, this is a language. A good question here. The question is, what does this mean? Like, what is some of the things that we have done already, right? So maybe we have alternatives to signals have been exhausted. So the warrant does provide, if you go back up a little bit, there are some ideas for what are some of the alternatives to traffic signals, right? So they do talk about that. If you go back up, alternatives to traffic control signals. So these are the things that you should be looking at. Installing signs along major street to warn road users that signal is approaching. Relocating the stop sign to make, and installing measures designed to reduce speeds on approaches. Flashing beacon on interception to supplement the stop control. All of these things have been sort of implemented, right? So revising the geometrics. So these are some of the things that you need to, so you maybe have exhausted the warrant for other types of controls, like, for example, the stop sign warrant. If you don't have the stop sign yet, those are the types of things you need to be looking at before you can. So they're basically what they're trying to do here is it's trying to get you to think about not just putting the signal because you meet like one warrant. Okay. Now, so this was sort of the 8-hour warrant. And now, we can probably go to the next one for the 4-hour warrant. And 4-hour warrant, 8-hour warrants are basically the same. So instead of like having these sort of charts, like this sort of table, now you have a chart where you're going to start putting dots on this chart. Okay. Again, very similar. Minor street, higher volume. Major street, total of both approaches. You have these different curves, and you're going to start to put those points on the curve. And again, let's assume which chart are you going to use? Because I asked you to assume that, and you're going to assume that for the whole problem. So are you going to use chart 4C1 or 4C2? 4C2, right? Because we're going to use 4C2 because I asked you to assume that 70% factor because the speed is above 40 miles an hour. So what I want you to do next is I want you to start putting in these points on your chart and see if 4 points lie above these charts, right? So basically you're going to draw every hour, you're going to put every hour on this chart and see where that chart, where that point lies. Does this line, if 4 points lie above the corresponding curve, so we have to think about which curve are you going to use, right? You're going to use this middle curve here, right? Because 2 or more lanes and 1 lane. So major street has 2 or more lanes, minor has 1 lane. So that becomes your guiding curve. And then you're going to decide whether or not you meet that criteria. Again, you can see the curve sort of flattens out after you reach like such a high major street volume. The curves sort of become pretty flat. And then, so yeah, your goal is to now start to see if we can where would we place those 4 points? Again, look through that 4-hour vehicular volume warrant, much more simpler in nature, because again, a lot of that terminology can be adopted from the 8-hour warrant. And let's try to see. So, and I want you to exercise that option, the 70% option. Okay, so let's start to put some points on this chart. Talk to each other, feel free to do that. That's always useful here in these types of problems, because questions do come up. I'm interested in what happens on. So 4-hour means you're just basically placing the points and seeing how many points are above the curve. I'm interested in, like, where would you put the 7 to 8 o'clock? Let's think about where would we put 7 to 8 o'clock curve. Or 7 to 8 o'clock hour. Would you put it 425 and 205, right? So 425 would be somewhere here. 450 will be here. So 425 will be here. And it says 205. So let's start to draw some lines here. Annotate. Drawing some lines. So 425, I would put it over here. And 205 is like right there, man. I would just kind of put it on the curve. So yeah, that's going to be interesting, right? So it's almost right on the curve, right? So I mean, you could interpret it however you want. So I would say, like, and then you have 420 and 210 the next hour. Basically the same thing. You got 420, which is like a little bit lower than this. But this one is a little bit higher. So maybe this one goes above the curve, right? So these points are like right on the curve almost. What about next one? 465 and 215, right? I'll probably put 465 and 215. Yeah, that clearly goes above the curve. So I'll probably make a mark here. Maybe I'll just draw like this diamond here. So I'll probably put that diamond over 465 and 210, right? 8 o'clock to 9 o'clock hour. So I'll put it over here. Sorry. 465. Yeah, it's kind of interesting. Yeah, so this one will be above the curve. What about 550 and 210? 550 and 210. Above the curve, obviously, right? If 550 will be further to the right, definitely above the curve. And then what else? 680 and 110. That's an interesting one too, right? 680 and 110. So 680 will be somewhere here. I'm going to draw the line. 680 about here. And then 110. Oh my God. Okay. Yeah, that'll be almost, I think this will probably just be above the curve also. 110 will be maybe just slightly above the curve, right? So just a little bit above the curve. I probably need like more precise lines here. But that's just the way it is, right? And then these days, you can find some Excel tools there that sort of rely on the equation, and you could use those for your analysis. Yes.
Well, can be on the one.
Yeah. So let's see what the language says here, right? So let's look at 4C3 and carefully figure out whether the language says above or can it be on the line. So what do you think here? Above the applicable curve. So yeah, it says not on the applicable curve, but above. So it does want you to be above the applicable curve, right? So yeah, I think, and then the last one is, so you could just sort of go through that. I think you could probably, yeah, I think you will meet this warrant. You will probably have like a bunch of them on the curve, and then at least 4 of them above the curve. So at least for that 70% condition, the warrant will be met. Now this warrant number 3, I think as an engineer, you probably should not use. A lot of DOTs recommend against using it now, because what you're doing then, and you could look at the volume threshold for peak hour. Again, very similar. You'll use 4C2. You will use 4C2. And then there is some condition for 1 and 2, but you could look at what warrant number 3 is about. So let's take a look at what it is about. But I personally do not recommend using it because, first of all, it's only 1 hour in the whole day. So even if there is delays that are just happening for 1 hour in the day, so you should not probably be worried about that delay, right? Traffic signal, you should be careful about putting it in, and putting it just for 1 hour of the day seems like the delay for the delay in 1 hour of the day seems like a bad idea to me, right? So peak hour warrant, if that's the only warrant you're meeting, be very careful about putting a signal. I would recommend against it. But again, different people might have different judgments. But again, it's just 1 hour of the day. I know we're right at 4:30 now, or getting pretty close to it. But questions? I know somebody had, Nick, did you have a question about the peak hour? Okay. So let's look at the peak hour condition as sort of like your mini homework, and come back and talk about it next week. We'll do it anyway. We'll apply it, and then we'll wrap up the discussion on the warrant. I did move the homework due date to be the coming Tuesday, not Thursday. So we are okay. And then our test date also is now moved. So yeah, we should be good there. If you have any questions, feel free to reach out. Make sure that you're making progress on your homework now. You should be pretty much able to solve all the problems. All the traffic signal warrants, we just got rolling on that, but you should be able to solve those problems as well. So once you're done with this in-class problem, make sure that you start working on those homework problems and get those done as soon as possible, okay? And I will see you Thursday, if not sooner, for the office hour.